So, a giant crater right in the middle of the cold permafrost of Siberia has been getting wider and wider for several decades, maybe centuries. We don't know. It looks like the doorway to the underworld, but its official name is the Devouring megaslump. It's like the Grand Canyon in cold conditions, which is getting bigger and bigger. Siberia is a rather harsh and gloomy region. Cold weather, endless dark forest with dangerous wild nature, no civilization around, and now we have this. Imagine that you live there in a dense forest in a small wooden house with a fireplace. And then suddenly, a giant pit starts crawling toward your house. It doesn't stop. It doesn't grow smaller. It just absorbs everything in its path. Trees, ground, bushes, bird nests, everything falls in there. What is it? The Devouring megaslump appeared after the collapse of a slope of the Yana Highlands. When the rock crashed, it exposed layers of permafrost on the remaining part of the slope. People first noticed it in 1991 with the help of a satellite. But who knows how long ago it appeared there? This ice sheet has been untouched for about 650,000 years, and now it has awakened and started to melt and grow continuously. Even scientists claim that this natural phenomenon, which looks like a giant manta ray, is expanding too fast. During the collapse, ice and sedimentary rocks melted in huge quantities. According to calculations, this mass was 14 times the mass of the Great Pyramid of Giza. In recent years, the rate of collapse of head walls ranged from 16 to 49 feet per year. And the total mass of the bowl-shaped retrogressive, aka RTS, is… Wait, what is RTS? This is a term that recognizes the crumbling relief of the bowl-shaped form. It can be erosion, ground collapse, rock deepening, and the like. So, the total RTS in the Devouring crater increases by about 35.3 million cubic feet per year. This volume is equal to about 400 Olympic swimming pools. But is this monstrous geological slope expanding into the depths? Fortunately, it's not. The melting of permafrost has reached bedrock and stopped, so there will be no sinkholes to the planet's bowels. Scientists also suggest that the expansion will stop sooner or later since the collapsing edges are approaching bedrock, located in the area of the nearest mountains. But before that, the hollow will probably absorb something very tasty for it. Scientists used satellite images to estimate the scale of this phenomenon. They saw that the doorway to the underworld could significantly expand thanks to absorbing the adjacent valley. This will happen over the next 2 decades. Also, there's the Devouring River on the hollow's path. A collision with the slump will change the course of the river, which will lead to increased erosion. This will cause big problems for some river and forest inhabitants. But let's hope that nature will take care of fish and animals. But the most interesting thing is that a fast-growing slump can lead to a natural phenomenon that once provoked the appearance of this slump. This is greenhouse gas emissions. Frozen sediments in the permafrost layers, nutrients hidden deep in the soil. All this will be released and will bring significant changes to the environment, such as an increase in temperature. Once, these weather changes led to the collapse of the slope on the Yana Highlands and the formation of the doorway to the underworld. The temperature here is above normal and regularly sets new records, so scientists are not surprised that the hollow is growing so fast. What can stop all this destruction? Only the return to normal weather conditions. But who knows when it'll happen? In any case, it's good that this crater is growing far from civilization. Just imagine if such a slump were moving toward a big city. People would probably be powerless and would have to evacuate urgently. And then we would have to watch a live stream from a helicopter, skyscrapers falling into a giant pit. Oh, by the way, you don't have to imagine that. A similar phenomenon is happening in California. Only instead of a giant slump, there is the Nyland Geyser. In simple words, this is a moving mud puddle or a moving geyser, the only one in the world. Unlike the Devouring megaslump, this lump of sludge is not that big and it will hardly expand. But it's acting much more weirdly. It's constantly moving, and no one can stop it. This mud puddle formed in 1953, about 5 miles northwest of Nyland, an Imperial County, California. It was a typical mud cauldron. It formed, waited, did nothing, and then decided that it didn't care about all the geological laws, so it just went west sometime in 2007. Perhaps it happened later, but no one knows for sure. In the beginning, the puddle took its time and moved quite slowly, but in April 2018, it had accelerated. It turned out that it had passed 280 feet from the formation site. That's about 3.5 times the length of a tennis court. How does it move? And why won't anyone stop it? Oh, people tried. When the puddle began to approach the Union Pacific Railroad, engineers built a wall going into the ground to a depth of 80 feet. And you know what? The moving dirt just penetrated underground, seeped under the wall, and came back out on the other side. What is it? Where does it go? And how did it form? Scientists don't know, but there are theories. California has the Salton Sea. This is not actually a sea, but a grounded saline lake with shallow water. There are many mud cauldrons on the eastern shore of this lake. Nyland Geyser appeared among them and began to move. Some scientists suggest that the bedrock of this geyser is more permeable. That is, dirt and water easily seep into this geyser and make it move. This is something like a sieve that appeared as a result of frequent earthquakes. In addition, this region receives a lot of precipitation, which flows here from the Grand Canyon across the Colorado River. It also accumulates a lot of natural gases and heat from magma that flows under the Earth's interior. Add tectonic activity to this mix and you get conditions that allow a large mud puddle to move. Scientists have the pieces of the puzzle, but no one can put them together into one single picture and find the exact reason for its formation. And while the scientists were thinking, the puddle approached the Union Pacific Railroad. When the wall didn't help and the geyser continued to move, the railway management redirected trains to temporary tracks that they had built in case of an emergency with the puddle. People came up with different ways to stop the moving geyser. They tried pumping water out of the geyser, sprinkling its edges with ground, reducing pressure, and much more, but nothing worked. By August 2019, the puddle had become a threat to Highway 111. The State Transportation Department closed the road and built a bypass. This forced drivers to detour and spend an hour and a half driving around the western shore of the Salton Sea. Now, the puddle has slowed down, but everyone is waiting for what will happen next. Who would have thought? Spaceships from other galaxies, meteorites, a zombie apocalypse, global cataclysms. We imagined so many possible threats to humanity, but it turned out that a moving puddle of mud could cause huge problems. Fortunately, this doesn't frighten people living in the state. Geologists, engineers, and builders look at this phenomenon with delight. It's a miracle of nature, and people can't do anything about it. Although, if you think about it, surely something can be done. For example, dig a hole in front of the puddle and set a big fire inside it. It would be funny if the puddle puts out the fire and moves on. In any case, it's interesting to see what happens next and where it's going.
Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads up about volcanic eruptions years before they happen. With this new weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaros, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in a rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the Earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleyside and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say. Guam is not like any other island. It should be, from the looks of it, a peaceful green paradise in the vast blue of the Pacific. But something happened here that changed this place forever. Guam was invaded by awful little creatures, millions of them. Ecologists can't catch a break in this place. One time they had a cool island get-together. People roasted a whole pig over a fire, laughing and talking. But when everyone stepped away for just a moment, something else decided to crash the party. When they returned, they saw it, a thick snake wrapped around the roast pig. Its eyes shimmered under the fading firelight, scales reflecting the embers. It was eating, swallowing the chunks of pork whole. A brown tree snake. This creature wasn't supposed to be here in the first place. It's an invasive species. It crept onto a cargo ship back in the 1940s, and in the years that followed, it couldn't stop bothering the island's true inhabitants, the birds. Guam was once a paradise of chirping, singing life. Its forests were home to 12 species of birds, so the air was always filled with beautiful whistles and calls. That is, until the snakes came. They slithered through the trees, finding nests, devouring eggs, and wiping out entire generations before they could even hatch. And in just 40 years, the jungle fell silent. Out of the 12 bird species, 10 are completely extinct. The last 2 are barely clinging on. The Guam kingfisher is a funny bird with a cute long beak. It was only saved by a last-minute effort to capture a few survivors. It went extinct in the wild, but ecologists managed to keep them in zoos for decades. And thankfully, there is great news. This year, things have improved for these guys, and now scientists released a handful of them in the jungles about 3,600 miles away. Another barely saved species is a Guam rail, also called coco by the locals. The poor thing can't even fly, a ground bird completely defenseless. Thankfully, people relocated these guys on other islands and helped them make it. But the true horror of the brown tree snake wasn't just its hunger, it was its stubbornness. Now, most predators only eat what they need, but brown tree snakes, they stop at nothing. These guys have zero chill. They'll go for animals that are too big for them to swallow. They'll try to eat random stuff like trash. And if they realize that they literally took a bigger chunk than they could bite, they'll just leave the leftovers to rot. It's horrifying. When researchers were trying to understand why the birds were disappearing suddenly, they gave them tiny radio transmitters to track their movements. But every time scientists went to check on tagged birds, they kept finding the tracking signals inside the snakes, or in bodies left by the snakes. Oh, and now these snakes have nothing to eat. Millions of them. You'd think they'd just give up, but nope, they decided to change their diet. Rats, lizards, garbage, each other. Yep, these guys aren't picky. What's even crazier is that it was just the beginning. Birds aren't just there to sing pretty songs. They eat things like bugs and help keep nature in balance. And when they disappear, you can tell because something starts taking their place. Spiders. Guam's spider population absolutely exploded. The place is drowning in silky webs and creepy little legs. Especially the banana spiders. Giant golden-bellied creatures that build sprawling webs bigger than anything seen on other islands. Or the huntsman spiders, the size of a human hand. Like the name hints, they chase their prey down the island, skittering across the jungle floor, and use fangs to inject venom quickly. Tiny Argyle Road spiders are also lurking among them. These are sneaky little thieves that steal food from their much bigger neighbors. Sometimes they even eat those neighbors. And finally, the tent web spiders, whose webs are like entire cities. They create a single mass of silk where dozens, sometimes hundreds of spiders live together. Some ecologists call them condo webs, like some multi-level apartment complexes. These condo webs stretch from the ground all the way up to the jungle canopy, so the forest starts looking like a Halloween party. You can wrap into these things like a mummy. It became so common that hikers started carrying spider sticks, long branches used to sweep away the webs before they got caught in their faces and clothes. Recently, in 2012, they finally decided to count all these guys. Well, you'd never guess it. From 500 to 730 million eight-legged creatures in the jungle. The island has 40 times more of them than other places nearby, like islands of Rota, Tinian, and Saipan combined. And that's a low estimate, because some webs are not within an arm's reach. And these guys keep evolving too. The banana spiders usually weave something called a stabilimentum. It's a zigzag pattern of thick white silk woven through the web. Though scientists aren't entirely sure why they do it. Maybe it strengthens the web or makes them look bigger or scarier. The strongest theory is that it warns birds. The bright, thick pattern tells them not to fly around here because they'll ruin everything. Oh, but on Guam, you don't have to worry about the birds at all. So now they stop decorating their webs entirely. The worst part is that no one really knows how to fix this. To protect one of the species called the Micronesian starling, ecologists built nest boxes, safe enclosed spaces where the birds could raise their chicks. To make sure snakes couldn't reach them, they installed smooth metal poles beneath called baffles. The idea was simple. The poles were too wide, too slippery. The snakes wouldn't be able to climb them. Well, that was the hope. These brown tree snakes decided to lasso the poles instead of climbing them. One snake, thin as a rope, wrapped itself completely around the metal cylinder, coiling into a loop. Then it began shimmying up the pole. Scientists only discovered this in 2021. They've never seen a snake pull this one before. They literally refuse to leave the birds alone. Humans have tried everything. Trapping them, building barriers, scouring the forest with flashlights at night, setting up fences. But nothing has worked, so far. There are just way too many of those guys, and they're all too smart. Now, just so you know, the U.S. spends nearly $4 million every year trying to control this disaster. But the only real success is a single tiny patch of land at Andersen Air Force Base. Scientists managed to drive down the snake population there using bait. But the truth is slowly sinking in. The snakes aren't leaving. Humans can send rockets to space, but this is too much. That also means that Guam Island will start looking entirely different soon. Guam's forests always felt mysterious and kinda creepy, even without the invaders. There's no soil, no soft place to step. Instead, it's all jagged, broken limestone. Everything is full of razor-sharp rock left behind by an ancient coral reef. It was being pushed up over millions of years. Trees force their roots into the cracks. Everything is packed with twisting and curling plants. Breadfruit trees, prehistoric-looking cycads, spiky pandanus trees. And just as a cherry on top, a typhoon comes ripping through every few years, tearing it all apart. Luckily, plants usually grow back fiercely. Now, walking there is insane. It feels like walking in the sea, though instead of balancing on waves, you're trying not to trip and gash your shins open on the sharp rocks beneath you. You have to think through every step. But now, things are going to get so much worse. 70% of Guam's trees relied on birds to carry their seeds, spreading them far and wide. So, without the help of birds, the trees drop their fruit directly to the ground, where it sits and rots, so nothing grows. Well, perhaps the invaders' rule over Guam may last forever, and soon this place won't be friendly to tourists at all. It may become one of the worst places on Earth, if it isn't already.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events, like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, That means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever Anita has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They published the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice. Just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Whistle and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now. building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
A long, long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes-Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region, a strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes-Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes-Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still, scientists haven't put the Wilkes-Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes-Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. but the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land Anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future. Stonehenge is famous, but it isn't the oldest UK monument of its kind in England. That title belongs to Flagstones, a site that predates Stonehenge by about 200 years. In fact, It's possible that whoever built Stonehenge might have been copycats, or perhaps, as some prefer, inspired by flagstones. Let's start unraveling the mystery of flagstones by looking at its exact age. To crack this ancient puzzle, scientists turned to a powerful technique: radiocarbon dating prehistoric monuments. This method works on organic materials like wood, bone, or charcoal that are up to about 60,000 years old. Each of these materials contains something called carbon-14. When an organism passes away, its carbon-14 starts to break down at a predictable rate. By measuring how much is left, scientists can estimate the age of these ancient objects. The method is really impressive, so it doesn't come as a surprise that the inventor of this method was awarded the Nobel Prize. Radiocarbon dating has revealed that people built flagstones around 3,200 BCE, making it older than even the earliest parts of Stonehenge. But the mystery of flagstones is just beginning to unfold. Flagstones is located in Dorset, in southwest England, about 37 miles away from Stonehenge. It was discovered in the 1980s when workers were building a new road. Archaeologists dug up a huge circular ditch about 330 feet wide, made with overlapping pits. Inside the pits, they found the remains of at least 7 people, a cremated adult, 3 young individuals, and 3 other adults whose bodies were partly cremated. This shows that people could have used the site as an ancient cremation burial site. Flagstones is basically a big, ancient circle that popped up right where early farming communities were spending their time. If you went there today, you wouldn't see any obvious walls or banks, but if you look inside the pits that make up the circle, you'll find chalk rubble from both sides. That's a clue that when people dug these pits, they used the dirt and chalk they took out to build up banks both inside and outside the circle. This special spot sits right in the middle of a whole bunch of other really old monuments and sites, which were built over thousands of years during the Neolithic and Bronze Ages. Experts have figured out the ages of some of these nearby places really well. For example, the ditch at Maiden Castle dates back to around 3,600 BCE, and the Big Henge at Mount Pleasant was built around 2,600 BCE. Today, half of flagstones is under that road, and the other half is under an old historic house looked after by the National Trust. You can find objects from the site at the Dorset Museum. Because flagstones and early Stonehenge look so similar, with round enclosures, pits, and cremated burials, scientists used to think they appeared at the same time. But thanks to radiocarbon dating, we now know flagstones, this ancient cremation burial site, is the earliest big circular monument ever found in Britain. To figure out how old the site really is, researchers tested things like human bones, red deer antlers, and charcoal found there. One of the most puzzling discoveries was a young man who was buried under a huge sarsen stone in the middle of the circle. Someone left him there about 1,000 years after people used the site for the first time. This find just added to the mystery of flagstones. You're probably wondering about the flagstones versus Stonehenge comparison. Well, the latter is a mystery on its own, a big old circle of giant stones in the south of England. Those who made it didn't write anything down, so we don't know exactly what they were thinking. One old tale says that King Arthur's wizard, Merlin, used magic to move the stones from Ireland, where giants had put them together. Another story says that people from Denmark built it. Today, some people think extraterrestrial visitors made it. A man named John Aubrey started studying Stonehenge in the 1660s. He thought the Celts had built it for their priests, called Druids, but that turned out to be wrong. Radiocarbon dating of this prehistoric monument shows that its constructors built it in phases over several centuries. The construction started around 3,100 BCE and continued till around 1600 BCE. First, about 5,000 years ago, it was just a round ditch in the ground. Then people added wooden posts. Around 2,600 BCE, they brought big blue stones from Wales. Later, they added sarsens, even bigger stones, each weighing as much as 5 elephants. They moved those stones from 19 miles away and placed them in a big circle with 5 tall stone arches shaped like a horseshoe. Experts think building Stonehenge took more than 20 million hours of hard work. And that's a lot of teamwork, strength, and planning for people who didn't even have machines. These days, there are a few different ideas about what Stonehenge was really used for. Some experts think it was a sacred place where people gathered for religious ceremonies. Others believe it was an early kind of science center used to study the sky and track time. Both groups notice that the stones at Stonehenge are lined up with the sun and moon, so people may have used the site to mark the changing seasons, especially during the summer and winter solstices. Some think it worked like a giant calendar, helping people figure out dates or predict things like solar eclipses. Stonehenge was an ancient cremation burial site too, at least for some time. Anyway, if we continue with the flagstones versus Stonehenge comparison, we can't but dwell more on the age of these monuments. Flagstones is older than Stonehenge. In fact, it's one of the oldest UK monuments. It's really special because it's the most ancient big round enclosure ever found in Britain. According to the newest studies, its age is about 5,200 years old. After it was built, more and more round monuments started popping up in other places too. Before its construction, most ancient monuments were long and straight, like rectangular barrows or burial mounds, or long ditches called cursus monuments. Some had even more random shapes, but the Flagstones monument shows a big change. People were starting to build in circles instead. Some experts think this idea of circular monuments might have come from Ireland, where people were already burying cremated bodies in round tombs. On the other hand, even though Flagstones has turned out to be older than Stonehenge, the new findings suggest that Stonehenge might need to be redated. Some of the objects found at Stonehenge, like animal bones, are actually older than the main structure itself. For example, near the entrances to Stonehenge, archaeologists found deer bones and cattle skulls that date to around 3,200 BCE. Experts used to think that people kept those bones for a long time before burying them. But it's possible there was an early version of Stonehenge made from overlapping pits that existed before the big circular ditch was built around 2,900 BCE. Now, could Flagstones and Stonehenge have been part of a bigger shared tradition? Could there have been other ancient cremation burial sites in the UK? After all, these constructions aren't the only round prehistoric monuments in Britain. In Wales, there's a similar site called Llandagai, which also looks like a circular burial place. Such a way of burying the deceased might have been a common custom across the UK because you can see similar structures in Eastern Ireland. In the Boyne Valley, for example, there are ancient places like the Mound of the Hostages that people used in the same way. Now, researchers want to do more digging in Ireland to see if some of those monuments were built before 3,200 BCE. If they're even older than flagstones, they might help explain where the idea of building round burial sites started and why people across Britain and Ireland were building them. The more we learn, the better we'll understand what these sites were really for and how the people back then might have shared beliefs and traditions across the sea. Hopefully, one day, we'll figure out the mystery of flagstones, one of the oldest monuments in the UK.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, Researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynja went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynja. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynjas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynja isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data: satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynja sits above an underwater mountain called Maud Rise. During those big Polynja years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynja to form and stick around. Polynjas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron, and completely lacks oxygen and sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse.
In 2003, while following a grouper that suddenly disappeared below the waves in Chetumal Bay, Mexico, a lone fisherman discovered a mysterious hole hidden from sight. More than a decade later, his son returned with researchers to take a closer look. They started measuring. 100 feet, 160 feet, 425 feet. Still no bottom. As instruments descended into the dark, still water, the readings grew stranger. Warm, salty water where it shouldn't be. Currents rising from the darkness below. The latest readings showed over 1,372 feet and still no end in sight. Quiet, deep, and dangerous. It's Ta'am Ja, the latest and officially the deepest known blue hole on Earth, and it might be hiding something never seen before. Nature takes its time. Over thousands, sometimes millions of years, water slowly carves through underground rock. Then one day, the ceiling gives way, the ground collapses, and you're left with a massive hole. That's a sinkhole. Blue holes are just ancient sinkholes that filled with water as sea levels rose long ago. From above, they look like dark circular shadows, much darker than the water around them. All because they're super deep and sunlight can hardly reach the bottom. Some go hundreds of feet down and are almost perfectly vertical. Cut off from ocean currents, they create still, isolated environments that scientists are still trying to figure out. So, what makes Ta'am Ja unusual? Well, most famous blue holes like the Great Blue Hole in Belize are impossible to miss. You can spot them from a satellite. Ta'am Ja, on the other hand, is practically invisible. Like nature did its best to conceal it on purpose. Even with a drone flying right above it, it's barely noticeable. That's one reason it stayed hidden for so long. However, the true mystery became apparent after the researchers had done their initial scanning. In December 2023, scientists decided to explore the depths of Ta'am Ja by lowering something called a CTD profiler, which measures conductivity, temperature, and depth. As it went past 1,312 feet, they discovered something curious. Instead of cooling down, the water suddenly got warmer. It also became noticeably saltier, with readings that matched the open Caribbean Sea. But wait, Chetumal Bay is already part of the Caribbean, so what's the big deal? Well, Ta'am Ja is tucked far into the bay, and its depth is unusual for such a calm, protected environment. What surprises scientists is that water deep inside the sinkhole has the same temperature and salinity as the open ocean, even though it's cut off from it horizontally. What this means is that there could be subterranean tunnels or fractures connecting the deep hole to open seawater, not through the surface, but beneath the rock. Kind of like a secret pipe network, possibly dating back to the time of asteroid impacts. Ta'am Ja is located near the Chicxulub crater. It's where 66 million years ago, a giant meteor slammed into what is now the Yucatan Peninsula. It's widely believed to have caused a mass extinction event that wiped out dinosaurs. The asteroid didn't create Ta'am Ja, but it may have fractured the foundation, potentially making it easier for caves, tunnels, and eventually blue holes to form. Some speculate that these underwater connections could extend to other blue holes and hidden springs nearby. However, exploring Ta'am Ja is not just about maps and underwater tunnels. During the first expedition, researchers saw something strange. The water above Ta'am Ja was calm, while the rest of the bay had chaotic waves. Then, from the center of the hole, water started to rise upward, like a hidden spring gently exhaling. Not a geyser, not a splash, just a slow, steady surge, like something beneath had moved and pushed the water up. The fact that this happened only once made the following exploration intimidating for divers. They said that diving felt like encountering a living entity that moved and interacted with them in an intriguing and mystifying way. When you've got a place that deep, that dark, and completely cut off from the rest of the ocean, it's a door to the unknown. While it's probably too tight for the Lovecraftian sea gods to fit in there, it's not impossible that there could be species that no one's ever seen before, maybe even dangerous. It's speculative, but if the hole goes even deeper, any microbial life down there would likely be ancient and adapted to survive in extreme, hostile conditions. It doesn't have to be some scary sea creature. Even tiny, unfamiliar organisms could disrupt modern ecosystems if disturbed or released. There might be water from prehistoric times or something left behind from the asteroid impact that wiped out dinosaurs. This place might be hiding an entire ecosystem that's been sealed off for literally ages. And that matters because if life can survive in such a strange sealed-off place, it might survive in similar environments on moons like Europa or Enceladus. Also, some blue holes, like the Great Blue Hole, contain nasty stuff like clouds of toxic gas that can eat through equipment and even burn your skin. No wonder that divers felt like they were exploring something alive. Now, if you're wondering whether you can rent diving gear and actually go and explore this hole, the answer is no. Basic scuba gear requires certifications. Even dive shops won't rent to uncertified individuals, especially not for places like this. But even if certified, recreational divers can only reach a depth of about 130 feet. Going deeper takes special training, equipment, and a lot of caution. Even professionals rarely go beyond 1,000 feet, and when they do, it's with complicated, risky setups. At these depths, water pressure becomes a major obstacle, enough to crush most equipment not built specifically for it. So for now, Tom Jaw remains a mystery that's impossible to uncover while diving. The next stop is most likely sending an ROV, a remotely operated submarine equipped with cameras, arms, and sensors. It can go much deeper than any diver and stay down there longer. ROVs could help uncover layers of fossils, strange chemical zones, and even clues about past climate change. In most of the blue holes, it's possible to find life, sponges, corals, or fish. But the deeper you go, the more oxygen levels drop, which makes it hard for organisms to survive, even though some microbes live there. Among the few creatures found, there are shelled single-celled organisms called foraminifera and tiny worm-like nematodes. It's precisely because of these microscopic animals that we speculate that if life can make it in Tom Jaw's dark, salty, oxygen-free waters, maybe the same is true for other watery worlds. However, despite the enthusiasm around it, Tom Jaw is almost unnervingly empty and devoid of larger life. Even near the upper layers where oxygen levels are decent, no fish, no crustaceans, not even a tiny shrimp have been observed. Just tiny organisms invisible to the unaided eye. No bikini bottom, but to be fair, we haven't reached the bottom yet. Which brings us to the speculation. Is it possible that ROVs will never reach the ocean floor? The hole might be deeper than we expect or shaped in a way that makes it hard for our equipment to get accurate readings. It might have side tunnels, ledges, or twists that throw things off. It could also be that the walls are too unstable or the pressure and water chemistry mess with the sensors. In a way, it's like playing an underwater level in slow motion with a robot that can grab things and get damaged. Thankfully, scientists have other options. They can use underwater drones that work on their own, drop cameras that record as they sink, or map the hole from above using sonar. There's more than one way to check its depths. Even with all our technology, there are still places on Earth we haven't explored. We've actually mapped more of Mars than the ocean floor. Spacecraft can scan the entire planet while seafloor mapping is slow, costly, and limited by darkness and pressure. Still, Tom Jaw holds the record for the world's deepest blue hole, for now. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts. like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.